Yes, sir. Today we are discussing third semester numerical methods. In the numerical methods, we are discussing here in this one. Tell you the method of solving of equation, solutions of algebraic and transcendental equations, numerical solutions simultaneously in equation direct methods, numerical solutions simultaneously in equations by iterative methods, finite difference operators, Newton forward and backward difference interpolation, central difference interpolation, uh, and also we are taking a Lagrange's interpolation, Newton divided interpolation, inverse interpolation, least square approximation. వినబడుతుందా సంహిత?
Yes, sir.
సంహిత, I am audible?
Yes, sir.
సంహిత వినబడుతుందా?
Yes, sir. వినపడుతోంది.
సంహిత వినబడుతుందా? హలో
Sir, వినిపిస్తోంది, sir. It is clear.
Okay. Listen here, the numerical differentiation, numerical integration 1, numerical integration 2. So this is the part of the method of solving of the equations I am telling you. Where, which center, ma?
6th semester.
Which study center?
Study center Vijayawada, sir.
Okay. Solution of algebraic and transcendental equations here. Location of the roots, graphical method, bisection method, regular Falsum method, Newton-Raphson method and integration method here. An expression in the form of f of x is equal to a0 x x power n, a1 x power n minus 1, a2 x power n minus 2, plus a3 x power n minus 3. అంటే మనం 1, 2, 3, 4 and so on, n minus 1 into x, a not equal to 0, a0, a1, a2, a3 and so on are constants here, and it's said to be a polynomial of degree here. So these values of x which makes f of x0 is called the roots of the polynomial equation. Every polynomial of degree has exactly n roots. So therefore the f of x is equal to f of x. So this is the solution. For example, in this equation f of x is equal to 0. So we can call it f of x is equal to 0. It is called as a polynomial. Then it's called as a algebraic or polynomial equation. Are you understanding?
Yes, sir.
Just a minute. So see here, f of x is, for example, the equation x square plus 5x plus 6 is equal to 0. I am taking here. That is 2x cube minus x plus 4 is equal to 0. X power 5 minus x cube plus 3x plus 3 is equal to 0. All algebraic equations we are taking here. An equation f of x is equal with the constants of one or more the functions of algebraic functions. Exponential function, trigonometric functions is called as a, this is a transcendental equation. So suppose we log x minus 2x. So x square plus 5x plus 6x, x cube, x power 4, x power 5, you can take that algebraic equation. But log x minus 2, throw the 2x plus cos x minus 1, 8x cube plus log 2x plus 3 plus e power sin x. This is, we can try some transcendental equations we are telling. Suppose a normal x square plus 2x plus 1 is equal to 0. తీసుకుంటే మనం we are taking that, we are taking the roots of the values. Am I correct, Samhita?
Yes, sir.
అంటే మామూలు ఈక్వేషన్ తీసుకుంటే మనం రూట్స్ కట్టొచ్చు, కానీ x power 5 plus x power 4 plus x power 3 కట్టిన మనం రూట్స్ కట్టలేము. అప్పుడు మనం ఏం చేస్తాం, minus b plus or minus under root of b square minus 4ac.
Yes, sir.
So this is the locates of roots. So this is the graph. Locates of the group చూడు, the intermediate theorem. F of x is continuous real value function ab, f and f of b is opposite signs. Then the existence of at least a real root for f of x is equal between a and b. So this theorem helps the locating root equation. In fact, the base of the bisection method above theorem. See here, choose f of 0. తీసుకున్నప్పుడు ఏమవుతుంది, f of a అనేది x కింద ఉంటుంది, f of y is equal to f of x అనేది ఉంటుంది. Am I correct?
Not.
Then graphical method also we can see here. The method of quite useful and the equation of the equation f of x is written in the f of f1 x is equal to f2x. So then we plot the graph y1 is equal to f1x and y2 is equal to f of f2x in the same axis. In the x coordinates of the point intersection, two graphs approximate the values real roots is f of x is equal to. See here 3x minus cos x. Minus cos x and both ఏమైతుంది plus cos x. అవునా?
Yes, sir.
సో అప్పుడు ఏమైతే y1 అనేది 3x minus 1 y6 అనేది cos x అవుతుందా కదా?
అవును సార్, అవును.
మనం రాస్తాం ఎగ్జామ్ లో. So therefore, the draw of the graphs we are writing the same here. So then the graphs of y1 and the same coordinates shown the figure in 1.2. So I will show the graph here. So the approximate value of 3x minus cos x minus x is equal to 0.6. ఎట్లా వచ్చింది 0.6? ఇక్కడ చూడమ్మా 0 minus 1. సో అంటే సెంటర్ ఆఫ్ ద పాయింట్ ఇక్కడ సెంటర్ ఆఫ్ ద పాయింట్ తీసుకున్నాం కాబట్టి 0.6 రేంజ్ లో మన గ్రాఫ్ లో కనబడుతుంది. క్లియర్?
Yes, sir. Yeah.
To find the approximate value of e power minus x sin x is equal to 0, e power minus x is equal to sin x, y is equal to e power minus x is y2 is equal to sin x. ఇక్కడ మనం దాని గ్రాఫ్ లో సో 0.6 to 0.6 ఎందుకు 0.6 వస్తుంది నైబర్హుడ్ లో అంటే మనం ఎగ్జాక్ట్ గా కర్వ్ వచ్చింది. ఆ కర్వ్ లో మన గ్రాఫ్ లో x and y యాక్సిస్ మీద we are taking the values, so that the point is 0.6. clear? Samit? Okay. Bisection method. The method is based on the method is based on the application of the intermediate value theorem. So f of x is continuous on function defined on a comma b such that f of a and f of b are the opposite signs. F of a, f of b less than 0 in the root of f of x equal to 0 lies in the interval a comma b. For definiteness we are assuming that f of a less than 0, f of b greater than 0, we are taking here x1 is equal to a plus b by 2. So f of x1 is equal to 0, x1 is the root of the function, x1 is equal to g, f of x is equal to 0, f of x1 not equal to 0, therefore f of a x1 less than 0, f of x1 greater than 0, f of x1, f of b less than 0. Consider here f of x1 less than 0, f of a, f of x1 less than 0, so therefore a comma x comma 1. F of x1, f of b less than 0, we are taking the bisection interval x1 into b. So the intermediate values, so the second approximation, the root of f of x is equal to 0. Therefore, x is equal to a plus x1 by 2, x2 is equal to x plus x1 plus b by 2, according to the rules lies between x1 or x1 b. We continue the bisection procedure until the value of f of x midpoint in the last subinterval or f of x almost equals 0, but either by the degree of accuracy we are taking here. Then find the real find a real root lying between. So they correct two decimal places for the equation x cube minus 9x plus 1 is equal to 0 to bisection method. 2, I am substitute 2 cube minus 9 into 2 plus 1, and then the 2 4 8 minus 18 8 9 9 అంటే minus 9 అంటే less than 0, 9 ముందు 27 So 2 cube means 2 minus అంటే -9 వస్తుంది కాబట్టి f2 less than 0. ఇది ప్లస్ లో వస్తుంది కాబట్టి greater than 0. So f2 f3 మల్టిప్లై చేస్తే -9 -20. So less than 0 అవుతుంది. So therefore it will lies and 2 and 3 లో lies అవుతుంది. So a is equal to and b is equal to 3. The first approximation, the root of x is equal to a plus b by 2, that is 2 plus 3 by 2, that is 2.5. F of x1 is equal to f of 2.5 and 2.5 whole cube is 2.5 into 2.5 into 2.5 minus 9 into 2.5. That's one, that is minus 5.875. Since f of 2.5 less than 0, f of 3 greater than 0, so therefore 2.5 and 3, a is equal to 2.5, b is equal to 3, x2 is equal to a plus b by 2, that is 2.75. F of x2 is equal to 2.75 whole cube minus 9 into 2.75, it is minus 2.95313. So you have the values in the x is equal to values రాస్తున్నాను నేను 1 2 3 4 10 substitution 2 2.5 2.75 2.875 2.975 9375 9375 9375 9415 2.945. So 2 plus 3 by 2 2.5 2.5 plus 3 2.75 2.75 same 2.875 2.875 plus 3 2. అంటే by 2 చేస్తూ పోతున్నాను అన్ని వాల్యూస్ ఉన్నాయి. ఆ రకంగా f of x అని ఫైండ్ అవుట్ చేస్తున్నాను నేను ఈ రకంగా చేస్తే ఇక్కడ f of x అని ఫైండ్ అవుట్ చేస్తే చూడండి ఇక్కడ అన్ని 2.94 లే ఉన్నాయి ఇక్కడ 2.94 2.94 2.94 2.94 లే ఉన్నాయి. Therefore, since x8, x9, x10 coincide up to 2 decimal places, the required root of the given equation is x is equal to 2.94. Example, another example we are taking here. Compute a real root of the equation e power minus x is equal to 3, x is equal to 0. Correct the root of the 3 decimal places using bisection method. E power minus x is equal to minus 3x. That is e power 1.5 minus applying this 1.5 decimal method law, and the positive is a negative. So therefore f of 1.5 and f of 1.6 less than 0. Here root of f of x is lies between 1.5 and 1.6. So a is equal to 1.5 and b is equal to 1.6. The first approximation is x is equal to a plus b by 2, that is 1.5 plus 1.6 by 2, that is 1.550. So I am applying a values and b values, addition by 2, then f of x, and see here 1.511, 1.511, this is x6 and x7, both the values are approximate values of 1.511 came. So therefore we can write here 1.511, this is one condition. This is a regular False method. What is the regular False method? The bisection method guarantees that the derivative process will converge, but the rates of the convergence is very low. An attempt has been made to develop a method which has positive convergence. The method to false position of regular false method is one such method in this direction. So f of x is equal to where f of x is a continuous function. By choosing 2 points a and b such that f of a and f of b, 2 points are opposite signs or means negative. Suppose positive should be negative, negative should be negative, or should be positive. To find interval f of a b, the root exists for f of x is equal to 0. In this method, the fraction of the curve function f of x by the chord. The equation of the chord joining the points are a f of a, b f of a. Y minus f of a by x minus f of b minus f of a by b minus a. The point of intersection of the chord of the x-axis taken as the first approximation is the root obtained by the putting y is equal to 0. Minus f of a by x minus a. Minus f of a means that is f of b minus f of a by b minus a. Therefore, f of a by f of b minus f of a into b minus a. x1 is equal to a minus f of a by f of b minus f of a into we are multiplying with b minus a, or a multiplying with a into f of minus a into f of b minus b into f of a by f of b minus f of a. So we replace by b x1 and withdrawn chord joining the points a f of a and x1 f of x1 by the new point of intersection of the chord by x-axis. We are taking this second approximation x2 by the replacing with x1 x2. We take the place the chord as secant or the chord method here. So one example we are taking here. Find the real root of the equation x2 minus 2 x minus 5 equal to 0. Correct the 3 decimal places by using the regular function method. x2 minus 2x minus 5. So I am substituting 0. 0 minus 0 minus 5 0 1. 1 minus 2 minus 1 minus 1 minus 6 0. 2. Why I am taking up to 3? So regular Falsi method 3 decimal. They are asked here 3 decimal points. They are asked 3 decimal points. So now I am taking 3 means 3 points I am taking here. F of 2. 2 cube minus 1 3 27 minus 9 19 minus 5 so 16 minus it should be less than 0, so it should be positive greater than 0. So f of 2 f of 3 less than 0, but f of x is equal to 0. Because lies between 2 and 3. Why? Because this is the called here y is minus 5 minus 6. So here 2 and 3, what is minus 1 and 16? So therefore a is equal to 2 and 3. So we are taking here 2 and 3. The first approximation root is a f of b minus b f of a, f of b minus f of a. 2 into 16 minus 3 into minus 1 by 16 and minus of minus 1, 35 by 70. 32 plus 3, 32, 3 plus 35, 7, 35 by 7, you have to calculate that is 2.0588. So therefore, f of x into x into 2.0588 minus 2 into 0.88 minus 2 into 0.8 minus 5 is minus 0.3911. So 2.0588 minus and the whole cube just in simplification minus 0.3911. So therefore, the second approximation root is also x2 I am finding here. What is that second approximation? 2.0588, first one here. Then into 16. What is 16 here? So 16 here, the second approximation 16 greater than 0, I am saying 16 minus 3. So taking I am minus 3 into, so 3 is the formula, 3 into minus 3, 0.3911. 16 minus they are applying here 34.1141 plus 16.3911. So this 2.0813. Then f of x2, f into 2.0813 whole cube minus 2 into 2.0813 minus 5. So therefore, the third approximation of the root x3 is equal to 2.0813 into 16. Same I am multiplying the same equation the part here. So same equation I am multiplying here. So therefore the value is 2.0987. F of x3. So point I am multiplying the same here 0.0850. So what is the 2.087 and less than 0 here, that is f of 3. F of 3, what's the value is here minus 0.05. So therefore 0.9, it is a lies between 0.8807 and 3. So therefore that is the condition here. The fourth approximation we are taking here. So 2.0897 into 60 minus 3 into minus 0.0540 minus 0.0540. So there is a multiplication we are doing 33.5927 by 16.0540. And I am multiplying 2 into multiply and 3 into multiply again. I am adding the values here 2.0928 is the value. So f of x4 into f of 2.0928 into whole power cube minus 2 into 2.0928 minus 5 to minus 0.0195. So another one, f of 2.0928 less than 0, f of 3 greater than 0. The root lies between 2.098 and 3. A is equal to 2.098, B is equal to 3. The fifth approximation x5 is equal to 2.0928. So 2.039, continuing this process, we obtain the one 2.093, 2.095. So x6, x7, 2.0943, yes, here 2.09, 2.09. And then we are taking the values up to 6, 7, 8, and 2.09 is the same here. Then we can take that x6 coincide up to 3 decimal points. The required root that 2.094, 2.039, here 2.039, fifth one, here also 2.092, 2.94. 2.9, 2.0943 we are taking here. Then Newton-Raphson method. So in the Newton-Raphson method I am taking here. This method is generally used to improve the results obtained by one of the previous methods. Let x0 be an approximate root of the equation. x1 is equal to x0 plus h with the exact root. The difference between x0 and x1 is very small. F of x1 is equal to f of x0 plus h is equal to 0. Expanding it by Taylor series we get here. f of x1 is equal to f of x0 plus h, f of x0 h plus h f dash x0, h square by 2 factorial double dash h0 is equal to 0. Since h is very small, h square, h cube, h power 4 can be neglected. Hence, the above equation reduces to f of x0 plus h f dash x0 is equal to 0. So, okay, first derivation, second derivation, third derivation, fourth derivation we are taking here, which is equal to minus f of f x0 by f dash x0. F dash x0, the denominator should be not equal to 0. Why it is equal to 0? The value is 0. x1 is equal to x0 plus h, x0 minus f of x0 by f dash x0 is a better approximation of x0. This is the first approximation. So by starting of x1, you get the approximation of x2, x1 minus f of x1 by f dash x1. The successive approximation is given by x1 minus f of x1 by f dash xn, therefore n is equal to 2. The geometrically, this method is an initial approximation. x0 is the root of f of x equal to 0. The tangent to the curve y is equal to f of x to the point x0, x0. If this the tangent line the x-axis at the point x1, say x1 will be better approximation to it. So we draw the under tangent and the curve at the point x1 fx1 so that it cuts the x-axis at the point x2. Say x2 gives the next better approximation to the process should be continued, the desired activity attained. So therefore, this is the equation part here. So this is the one tangent. This is the tangent. This is the f of x1 and x0. This is x0 f not x0. This is the circle. This is what we are taking here. Example. Find the real root of the equation x cube minus 3x plus 1 lying between 1 and 2 up to 4 decimal places by Newton-Raphson method. X cube minus 3x plus 1. This is not minus 1 plus 1. That is the first derivation in here. D by dx cube 3x square, d by dx of 3x 3. I am substituting 1. I'm substituting 1 here. 1 minus 3 plus 1 in the first one. Not differentiation, I'm substituting given equation f of x. That is minus 1 less than 0, the lies between 1 and 2, minus 3 greater than 0. So we can choose the initial approximation x0 is equal to 1 and start the Newton-Raphson method formula xn plus 1 xn is equal to minus f of xn by f dash xn n is equal to 0, 1, 2. Putting n is equal to 0, x1 is equal to x0 minus f of x0 by f dash x0. F of x0, f of n is equal to minus 1. F dash x0, f dash 1 is equal to 3 into 1 square minus 0. So we are substituting a value x0 is equal to 1.5. Equal 1.5 minus 3 into 1.5 plus 1 is equal to 0.125. So again, f dash x0 also I'm substituting here. x1 is equal to 1.5 minus 0.125 by 3.75. See here, minus 1.25 by 3.75. 1.5 plus 0.00, that is 1.5. 333 we are taking here. Above x1 is equal to f of 1.333, 1.5 333 whole cube minus 3 into 1.5 333 plus 1 is equal to 0.0049. F dash x1 is equal to f dash of 1.5 333, that is equal to 4.053. We are substituting the values f of x1, x2. So therefore x2, that is of f of x2 value is 0. Now by f2, f3, x3, we have to find that when the 0 is came, that is x value is equal to, that is 1.5321, that is up to 4 decimal places we are taking here. Find a real root of the equation. We are taking here x sin x plus cos x is equal to 0. X n x plus cos x, x n x plus cos x minus sin x, I am taking here a derivation. What is the derivation here? D by dx of x is constant. D by dx of sin x is equal to cos x. Again, sin x d by dx is equal to 1. D by dx of cos x is equal to minus sin x. So minus sin x plus sin x cancel here, x cos x here. I am applying the 0 into sin 0 plus cos 0, 1 greater than 0. So minus by applying that is 180 minus 1 less than 0. The root of f of x lies between 0 and 5. We choose the initial approximation 3.1416. Newton-Raphson formula xn minus f of xn by f dash xn equals 0, 0, 1, 2. x1 x0 minus f of x0 by f dash x0. So therefore f of x0 is equal to f of 3.1416. That's why I am applying Then sin 3.1416 plus cos 3.1416. Then apply the values we have to deliberate that one, that is minus 1. F of x0, f dash x0 also the same values and finding over here. This is x1 is equal to 3.1416 by minus 1 by 3 minus 3.1416. So there is a values we are written here. This is the fundamental conditions here. So you have to see here 2.283 into sine into cos. This is the values of the calculator. F dash also, this is the values of the calculator. X1 minus f of x1 by f dash x1 into 2.8233. So 2.8233 minus 0.0247, 2.7986. F of x2 is equal to 2.7986 values rasamu. So therefore f of x3 is equal to 0. So when the value is 0 coming, just we are taking here the Newton-Raphson method also is often square root of cube root of positive integer. This further illustrated with the some examples we are taking here. Often root correct the 4 decimal places by Newton-Raphson method. X square is equal to x square minus 2 is equal to 0. X square and this is f of x is equal to, I am taking this is x square minus 2. X square is the that is x square is equal to 12 come to the left side, x square minus 2 is equal to 0. F dash xn, that is 12 is the constant here. X square minus is equal to 2x I am taking it. So 1 applying here, 1 minus 12 minus 1, 2 applying minus 8. So therefore f of 4 between minus 3 and 4 it is lying here. So f of xn plus 1 is f of xn minus f of xn by f dash xn. Putting in is equal to 0 formula, we can get here x1 equal to x0 minus f of x0 by f dash of x0. So f of x0 equal to f3 is equal to minus 3, f3 is equal to 2.3 is equal to 6. 3 minus 3 by 6, 3 plus 1 by 2 is equal to 7 by 2. I am applying that value. 18 plus 3, 18 plus normal of 18 divided by 1 by 2 understood. That is 1 by 2, 3 by 7 by 2, that is 3.5. The 6 plus 1, 7 by 2 LCM is to take. F of x1 is equal to f of 3.5, 3.4 square minus 2 is equal to 0.25. F dash x1 is equal to f dash 3.5, 2 into 3.57. x2 is equal to x1 minus f of x1 by f dash x1. 3.5 minus value of minus 2.507, that is 3.4643. F of x2 is equal to 3.4643 whole square minus 12, 0.0014. F dash derivation would until here 3.641. And the 4 decimals we are taking here 3.4631 up to 3 decimals we are taking here in this method. Then iteration method. What is iteration method? In integration method, this method is known as also successive approximation method. Successive approximation method. And so they describe the method of finding the roots. How that is except see here x of 5 is the many ranges of x2 plus x2 minus 1 is equal to 0. 1 plus x whole 4 minus 1 by 2, 1 minus x whole 4 minus 1 by 2, 1 minus x square 1 by 3. That will be the initial approximate value of the desired root. Substituting for the side of the, we can obtain x1 is equal to 5 of x0. The successive approximation x1 is equal to 5x0, x2 is equal to 5x1, x3 is equal to 5x2, x4 is equal to 5x3, x5 is equal to 5x4. So xn is equal to 5 of xn minus 1. We are taking a 5 dash modulus of 5 dash x less than, and the successive approximation is covered. In fact, it can be shown that the smaller the value, more is the convergence. It's proof of the omitted here being the beyond of the scope of this present. Here did not want to use. However, if of x is considered x is to by x at some forms, iteration process may not be convergent to all. It is instructive to look at the geometric picture of the integration process. With simplicity, we denote the successive approximation to the root x0, x1, x2, x3, and so on, xn. Then the relations x1 is equal to 5, x0, x2 is equal to 5 on x1, x3 is equal to 5 of x2, can be shown that defined by all the following geometry. distributions we are taking here. I dash x less than 1, y is equal to phi of x, be less than 45 degrees neighborhood of x naught. See here, this is the first one, y is equal to phi naught x, p1, p2, p3, we are taking phi 1, x1, y1, phi 2, x2, y2, phi 3, x3, y3. So now the convergence of the integration process, now the coordinate phi x naught now. So y1 is equal to x phi 1, phi 1, x2, phi 5, x naught. Note that the point 5 is the geometric representation of the first integration x1 by x0, p1, q1, p2, q2, q2, p2, p2, q2, p2, q3. Anyone we have taken indicated by arrows p3, q4. But in this coach of the point q1, q2, q3, we are taking the approximate with the point of intersection of the curves y1 is equal to x1 by 2 by integration procedures. To find the real root of the equation f of x equal to x2 plus x square minus 1 is equal to 0, which lies between 0 and y using integration method. F of x is equal to x2 plus x square minus 1. So we are taking here, I am applying 0 plus 0 minus 1 less than 0. 1 means minus 1 plus 1 cancel. We know that 0 and 1. One negative, one positive, there is a lies between these numbers here. So therefore, x square plus x plus 1 is equal to 1. X is equal to 1 by root of x plus 1. The x is equal to phi of x equal to 1 by root of x plus 1. So minus 1 by root of 2 into x plus 1 whole power 3 by 2. Clearly phi dash x equal to 1 by 2 into x plus 1 whole power 3 by 2. Less than that is x belongs to 0. Hence we take x not equal to 0. In any the sequence of the successive approximation, that is successive approximation x0, x1, x2, x3, x4, xn. x1 is the phi of x0, phi of 0 that 1 by under root of 0 plus 1, that is 1. x2 phi of x1, that is 1 by under root of 1 plus 1, that is 0.701. The second one by 0.071 and x2 and x1 కాబట్టి ప్లస్ 1 తర్వాత వచ్చిన వాల్యూ ఇక్కడ వచ్చిన వాల్యూ ఇక్కడ సో ప్లస్ 1 ఇక్కడ వచ్చిన వాల్యూ ఇక్కడ సో we are taking that values as usually 0.7554 x6 phi of x phi of 0.7554 1 by root of 0.7554 that is 0.754 x7 0.5 of x6 phi of 0.7548 1 by 0.7548 అంటే దాన్ని 0.1.7548 అని అన్నది కట్టి దాన్ని రూట్ వాల్యూ చేస్తే మనకు కావాల్సిన వాల్యూస్ వస్తాయి. So this is the x7 and xn both are same here. See here, both are same here. So the decimal cost of approximation is 0.75. Find the real root of the equation 2x minus log 10 is equal to x equal by using the integration method. F of x is equal to 2x minus log 10 minus log 10 x minus 7 is equal to 0. So 2 we are substituting the values by integration method. 3 I am substituting f of 2 into 3 log 10. So 2 into 3 6 log 10 3 value 0.4771 minus 7. So we are just right 2.48 log 10 minus 4 value 0.60 value. That is negative, that is positive. So therefore between 3 and 4 it is using here. It is using here. So x is equal to 1 by 2 into 7 plus log 10x and therefore 5x is equal to 1 by 2 into 7 plus log 10x. So therefore 5x is equal to 1 by 2 log 10e by x. Log 10x is equal to log e x of equal to log 10e. So 0.4343 by 2 into 1 by x. So therefore 0.4343 by into x belongs to 3, 4. We take x naught is equal to 3 with the sequence of the successive approximation. How we can orientate to x0, x1, x2, x3, x4. So x1 is equal to phi of x naught, phi 3 1 by 2, 7 plus log 10 3. So 3 7 log 10 3 value ఎంత వచ్చింది log 10 3 7 point change వచ్చింది కదా. So I am writing here 7.447 by 2 by 2 x1. So here 7 point, so log 10 value apply చేస్తాం. So 7.527 by 2 7.5782. So we are 7 plus log 10 value, log 10 into 3.8764 value plus 7. Log 10 into 3.7386 value. Then log 10 3 log 10 3 7 value I am taking here. And also export 5 x3 5 into 3.871. The log 10 3.7891 plus 7. Log 10 3.7893 plus 1. Or values calculation on cross values. Since x4 x5 concerns go inside 3.7893. So here 3.7893 3.798. So therefore x is equal. At 1 to 3 values 1 to 3 values of values drawn in the root. The simultaneous equation in several unknowns. The real solution of the simultaneous algebraic transcendental equations in several unknowns can be found either by the Newton-Raphson method or by the integration method. We shall give an outline of each method of the equations two unknowns. Newton-Raphson method. Consider the system of equation f of x equal to 0, g of x equal to 0, that x0 y0 is equal to an initial approximation to the root. The rate we are taking here the system of equation that x1 is equal to x0 plus h and y1 is equal to y0 plus k. With approximation where h and k are small. Expanding f and g by Taylor's theorem for function two variables about 0.1. F of x1 y1, f of x0 plus h y0 k, f of x0 y0 plus h dou f by dou x x0 y0 plus k into dou f by dou y x0 y0. G x1 y1, g x0 plus h y0 plus k, g x0 y0 plus dou g by dou x x0 y0 plus k into dou g by dou y x0 y0. In the terms of x plus k square, higher power of h and k, we are taking x1 y1, x0 plus h plus y0 k, this one. So f of x1 y1 0, g of g of x0 y0 plus h into dou g by dou x at a partial integration is going to dou g by dou x0 y0 is equal to 0. Then h into dou f by dou x x0 y0 plus k into dou f by dou x0 y0 is equal to minus f of x0 y0. h into dou g by dou x x0 y0 plus k into dou g by dou x0 y0 minus g into x0 y0 j into f of g dou f by dou x dou f by dou y then dou g by dou x and dou g by dou y. The partial integration not equal to 0 here. The equation 2 and 3 can be solved h and k. In the linear equation 2 and 3 have the unique solution for h and k. X1 equal to x0 is to y1 is to y0 plus k. The approximation of the solutions x and y we are taking here by the integration method. Here consider the system of equation here. F of xy is equal to 0 and g of xy is equal to 0. When they written the form x is equal to phi of xy, y is equal to psi of xy. Therefore, phi psi satisfying the conditions of the convergence here. We are writing both models of both phi dual psi y both psi y both phi. Is there one low psi x? Low phi with low psi plus low psi x0 y0 is the initial approximations we are writing here. The sequence of the successive approximation is psi of x0 y0 is equal to y0 is equal to psi and phi psi x0 y0 psi x1 y1 psi psi x2 y2 x2 y1 phi x2 y2 psi x3 y2. See here x0 y1 x0 y0 x1 y1 x2 y2 psi phi and but inside x1 y0 x2 y1 x3 y2 x1 x2 x3 y0 y0 y1 y2. There is a difference between the psi and phi. The procedure will continue through successive. Find the real solutions. X square minus y square is equal to 4. X square plus y square is equal to 6 by using the Newton-Raphson method. So x naught is equal to y naught is equal to naught to 2 root 2. So therefore x square y square is equal to what is the value 4. So plus 4 and 2 minus 4 x square plus y square minus 16. Dou f by dou x. See there this is 2x. So in the if we have x we are taking y is 0, therefore dou x is constant 0. Therefore y here y dou f by dou y. So this is 0 2y minus 2y. Again x here 2x is 0. Again minus 2y. So plus 2y is minus 2y. So 2x 2y 2y. X naught y naught is equal to 2 root 2. There we have dou f by dou x, dou g by dou f by dou y, dou g by dou x and dou x by dou y. Values are writing 2x minus 2y, 2x 2y. So cross multiplication 2x into 2y, 4. 4 root 2 minus 4 root 2. Applying 2 root 2 minus 2 root 1, applying these values in the lower and upper bound. So 32 4 16 16 32 32 32 convergency satisfied. If 0 is there, is not convergency satisfying. If 0 not 0 means it is satisfied. So the system of linear equation of Newton-Raphson method. H into dou by dou x x naught y naught plus k into dou by dou x naught y naught minus f into x naught minus f into x naught y naught minus f naught into minus f naught into x naught. Therefore, so h into what is the values here? 2 into 2.8 into 2.8 is written x naught 2.8 2.828. I am written here 2.828. Then k into 2 is 2.8. That is 2.82 whole square minus 2.82 whole square. After the simplification, we are writing here h plus k is equal. This is 0, 5.h into 5.6.6. So k into 5.6.6, the minus should be there here. So h plus k is equal 0 by something is 0 by 0. So this is the h minus k. This is the solving the equation here. H minus k is equal to 0.7072 from the beginning of the values. H plus k is equal to 0. We know the value of the above one. So h is equal to 0.360. K is equal to minus 0.3536. So first approximation is given by x1 x0 plus x6. X0 and you know that 2.28 here. X0 means you know that 2.28 2.828 minus h value we know that 0.53 plus minus h rasan values in y1 is equal to also for x0 y0 and x1 y1 in 1 and 2 by repeating the above process is equal to 0.01966. The second approximation is x2 y2 also. The same the values here we can do that. Are you understanding? Madhu, are you understanding? Hello? Mr. Madhu, you are audible? Use the integration method, find the real solution of x equal to 0.2.
Yes, sir. Audible, sir.
What is your name? What is your name? Use the integration method to find the real solution. X equal 0.2 square plus 0.8, y is equal to 0.3 x square. How to solve it? 0.2 x square plus 0.8 minus x is equal to the next one put up, then y and put up f of x value. The equation can be written as y is equal to phi of xy and y is equal to psi of xy. Phi of xy is equal to 0.2 x square, psi of x is equal to 0.3 x square plus 0.7. So dou phi by dou x is equal to 0.4x, dou phi by dou y is equal to 0. You could have dou psi by dou x. Here 0.3 y square we are taking here. 0.3 y square means y because 0.3 y square dou x is 1. X లో చేస్తాం కాబట్టి 1 కాబట్టి 0.3 y square. ఇక్కడ 0.4 ఇది ఏం చేసాము dou x లో చేసాం కాబట్టి x లో చేసాం కాబట్టి 0.4 0.2 into 2.4 0.4x. So therefore dou psi by dou x is equal to 0.6xy. 0.2 into 0.3 0.6xy. Constant is 0. Here also constant is 0. It is easy to x equal to 1, y equal to 1, the solution of the system we are taking here. Dou phi by dou x modulus of dou phi by dou x x naught y naught plus dou phi by dou y x naught y naught is equal to 0.4 into 1 by 2 plus is equal to 0.2 less than 1. Dou psi by dou x x naught y naught plus dou psi by dou y x naught y naught is equal to, I am applying the values of 0.3 into 1 by 4 plus 0.6 into 1 by 4. That is less than when the condition convergency satisfied here. Here, the first approximation also we are taking here 0.2 into 1 by 4 is 0.85. Any doubts? y1 is equal to 5 and x1 y by. I am substituting values y1, y2, y2. X is equal to 0.94945, y is 6.361. Any doubts? In the first unit, any doubts, ask me. No doubts, okay. numerical solution of simultaneous linear equation direct methods. This is a system of linear equations. Consider a system of linear equations x1, x2, xn, so on. Xn is given by a11 x1, a12 x2, a13 x3, a14 x power 4 plus a1n xn bn, 21 x1, 22 x2, 23 x3 and so on, 20 xn is equal b2, an1 x1, n2 x2 and so on, an xn is equal b1, b2, b3. In the matrix form of that, a11 a12 a13, 21 22 23, 31 32 33 and so n1 n2 n3 we are taking here x equal x1 x2 x3 xn, b is equal b1 b2 b3 bn, we are taking here and b b1 b2 b3 bn we are taking here. Here n into n matrix A is called as coefficient matrix we are taking here. So n into 1 matrix S is called matrix of unknowns, n into 1 matrix B is called as column as not constant. N into n plus 1 is equal to a11 12 13, that is a1n, 21 22 that is a2n, an1 n2 and so on, nm, b1 b2 b3 and so on bn. We call the augmented matrix of the given system of equations we are writing here. The system of equation X is equal to be said to be homogeneous system. All the dx is equal to 1 to n vanish, otherwise non-zero homogeneous systems. In this unit, we deal the direct methods, namely Cramer's method, matrix inversion method, Gauss elimination method, and Gauss-Jordan method. This method produces the solution. Any doubts? Ask me. Amaya. Cramer's method. A simple method of solving the linear system. Cramer's method. For Gabriel Cramer, this method has been found 1704 is birth is 1704 to 1752. So a11x1, a12y, a13 that is equal to b1, a21x plus a22y plus a23 is equal to b2, a31x plus a32y, a33 that is equal to b3. So this is system of equation. We are writing a11, a12, a13 first row, a21, a22, a23 second row, a31, a32, a33 third row, b1, b2, b3. Let the determinant coefficient of matrix a11, a12, a13, a21, a22, 23, 31, 32. This is a determinant matrix not equal to 0. If the 0 is there, all the values of the values also should be 0. So x delta is equal to x11, a12, a13, xa21, 22 degree, xa31, 32, 33. We are writing here. On applying of elementary operation C1 plus YC2 plus ZC3, we are writing here. And the addition we get here. X delta is equal to 1 a12 by 13z, a12 13, a21 x a22 by a23z, a22 28, a39 32 by 33 is equal to 32 33. So in the matrix form we are writing here b1 b2 b3 a12. b1 first we are finding x. So first we are taking the constant value b1 b2 b3. Then the delta 1 say delta 2. Second row will be removed a21, a11, a21, a31, b1, b2, b3. Constant values in the second column a13, 20, a13, a23, 33. Delta 3, a11, a21, a31, a12, a22, 32, b1, b2, b3. We are writing here. So that is x1 by delta, y delta, y is equal to delta by delta, z is delta by delta. In this one, this is known as Cramer's method. Cramer's method is the unique solution of the system of equation delta not equal to 0. If delta is equal to 1 or more, delta 1, delta 2, delta 3 not equal to 0. The given system of equation does not possess the solution. Delta is equal to 0, delta 1, delta 2, delta 3 is also 0. The given system of equation have infinite number of solutions. Tomorrow we will discuss the problem of this Cramer's rule.